All right, so now we are looking at another criterion, the Akaike's information criterion, or AIC. This is the name of a Japanese researcher. So the AIC in model selection suggests to choose the model that has scores lowest on this criterion. We have here a part that has something to do with the Gaussian log likelihood, which we'll show in a second. And here we have a penalty. K is the number of variables in the proposed model. I'm trying to minimize this expression. So the larger the model is, the more complex the model is that I propose, the more I'm going to penalize my criterion here, right? I will not discuss in detail where this is coming from exactly, but you can see it's approximately right. It suggests smaller models are better, or more parsimonious models. So here, I want to point out this contains sum of squares error divided by n, which is the maximum likelihood estimate of sigma, or sigma squared. This should be a squared. And the maximum likelihood estimate is not biased. Remember, we don't usually use that because usually we divide by n minus p plus 1. Okay, so here is the Gaussian likelihood. So the product of the densities and going through there as usual. And then at this point, I'm realizing that yi minus mu I is just the sum of squares error. And for the sigma squared, I put in the maximum likelihood estimator, both here and there. All right, so then something cancels. Very nice. We arrange something a little bit, and we're getting two terms, the one here in the back and the one in the front. And the one in the front, or maybe the two in the front, does not depend on which model I choose. The number of observations is always the same. Pi is always the same anyways. So it's constant for the model selection. On the back end here, depending on which model I choose, I will get a different sum of squares error, right? So something changes back here. So here I have the log likelihood, which I'm trying to maximize. And here I have the AIC, which I'm trying to minimize. But that doesn't contradict, because here I have a minus, and as soon as I multiply this by minus 1, I get here a plus sign, and then I'm trying to minimize. Okay, so that makes sense. The constant affects nothing. Now, the factor 1/2 also doesn't matter. I'm trying to minimize the AIC value. Whether I'm minimizing 1/2 times the AIC value or not doesn't matter. And any kind of factor that I have in here, I can always absorb in the penalty. So I can pre-multiply that with anything I want. All right, so our table as before, the best two models for each K based on the criterion AIC. We are trying to minimize AIC. I leave you to this question to figure out which one is the best model based on this criterion. And I end on, for completeness, the R code that generated the table on the page before. This is the end.